A structure built thousands of years ago still baffles our best engineers today. The forgotten blueprints of the ancients reveal a world where pre-modern societies engineered the impossible. We are about to journey across continents to uncover how they moved mountains of stone and built observatories that track the stars with pinpoint accuracy. By the end, you will understand the sophisticated systems of knowledge that made these wonders possible, forcing a complete rewrite of our historical narrative. How did civilizations without modern tools achieve a precision we can barely match? What does a single stone block weighing over 1,000 tons tell us about lost methods? This exploration will reveal that our ancestors possessed a genius we are only beginning to comprehend. What does true human potential look like when freed from the constraints of our assumptions? The Great Pyramid of Giza stands as a silent testament to this very question. It is a structure composed of over 2 million individual blocks of stone, with each one weighing several tons. To label such a creation merely as big is to miss the point entirely. An ancient engineering marvel is defined by a convergence of factors that, when taken together, defy straightforward explanation. It is not just about immense scale, but about the breathtaking precision achieved on that scale. It is about longevity, buildings that have shrugged off thousands of years of earthquakes, erosion, and human conflict. Most importantly, it is about the glaring technological gap, the chasm between the tools and methods we believe a society possessed, and the magnificent, tangible result they left behind. These are structures that, according to our conventional historical narratives, simply should not exist. They represent feats that seem to belong to a different age entirely, from lifting stones heavier than modern military tanks to positioning entire temples so they capture the first ray of the sun on a specific day with pinpoint accuracy. The true significance of these wonders lies in that very gap, the space between what we think was possible and the stone-cold reality that stands before us. It forces a fundamental question: have we profoundly underestimated the intellectual and technical prowess of our ancestors? By understanding this definition, we can begin to appreciate the specific marvels not as isolated oddities, but as a consistent pattern of achievement that pushes the very boundaries of the plausible. That single stone block at Baalbek waiting in its quarry is a question carved in rock. It weighs as much as 2 fully loaded jumbo jets. How do you move such a thing, even today? This is the enigma of megalithic construction, a global phenomenon where our ancestors treated stone like clay, quarrying, shaping, and lifting mountains into place. In Peru, the walls of Sacsayhuaman are a breathtaking jigsaw puzzle. Enormous blocks, some weighing hundreds of tons, are locked together with such precision that the joints are virtually invisible. You cannot force a razor blade between them. Across the ocean, the great stones of Stonehenge were dragged over vast distances and then hoisted into their iconic arches, the trilithons, with a stability that has endured for millennia. The sheer scale of these projects defies the simple image of workers using wooden rollers and rope. How could a society without cranes or hydraulics achieve such a feat? The theories are as fascinating as the stones themselves. Some engineers propose elaborate ramp systems that snaked across the landscape, or ingenious counterweight devices that acted like primitive cranes. Others look at legends and wonder if the ancients had discovered something we have since forgotten, perhaps a way to use sound or vibration to temporarily soften stone, making it easier to shape and move. While the specific techniques remain a mystery, the underlying theme is undeniable. These builders possessed a profound, almost intuitive understanding of physics and material properties. They knew how to distribute weight, manage friction, and create structures that would last for ages. This was not brute force. It was applied intelligence on a gargantuan scale. The methods hint at a sophisticated, possibly unified system of knowledge, a lost science of stone that allowed them to engineer the seemingly impossible. That profound understanding of physics extended far beyond moving earth and stone, reaching all the way to the stars. The Great Pyramid sides are aligned to the 4 cardinal directions with an accuracy of within a fraction of a single degree. To put that in perspective, this is a level of precision you would struggle to achieve without a laser theodolite or a magnetic compass, tools the ancient Egyptians simply did not have. So how did they do it? The answer lies not in the sand at their feet, but in the sky above their heads. Their ability to orient these monumental structures reveals a deep, practical mastery of astronomy. The pyramids are not just tombs, they are stone clocks and cosmic maps. Their narrow air shafts, often mistaken for ventilation, point like laser sights directly to key stars, including Sirius and the Belt of Orion. These stars were not random choices. They held immense religious and calendrical importance, marking the seasons and the annual flooding of the Nile. This alignment was the result of years, perhaps even generations, of meticulous nightly observation. Some researchers propose a brilliant method, using the circumpolar stars that endlessly circle the celestial pole and never dip below the horizon. By tracking the rotation of these eternal stars, ancient surveyors could have bisected the angle of their swing to pinpoint true north with astonishing accuracy. This was celestial engineering on a grand scale, a permanent representation of their cosmos carved into the Giza Plateau. Their belief in the sacred connection between the heavens and the earth was so powerful that they built a machine to embody it, forcing us to completely reconsider the sophistication of their mathematical and observational tools. But this mastery of physical and celestial forces may have extended into an even more intangible realm, the very nature of sound itself. Deep beneath the island of Malta lies the hypogeum of Hal Saflieni, an underground labyrinth carved from solid stone. Within its sacred chambers, something extraordinary happens. The stone walls are not silent. They are finely tuned instruments. Specific rooms resonate powerfully at a low frequency, a profound hum that scientists have found can physically affect human consciousness, altering brainwave patterns and creating states of deep meditation or heightened awareness. This is not some happy accident of geology. It is a feature, not a bug. Across the globe, the ancient passage tomb of Newgrange in Ireland channels sound in startling ways, creating echoes and amplifications that seem to defy the space's simple structure. Far across the Atlantic, the step pyramids built by the Maya also possess strange and powerful acoustics. A single clap at the base of the main pyramid at Chichen Itza produces an echo that does not sound like a simple reflection, but instead ripples back as the distinct chirp of the sacred Quetzal bird. How could cultures separated by oceans and millennia all discover the same principles of sonic manipulation? The evidence points to a deliberate and sophisticated science. The builders were not merely stacking stones, they were carefully shaping them, understanding that the density, curvature, and surface texture of the rock would dictate how sound waves would behave. They were, in effect, the world's first acoustic engineers, designing spaces where sound was not just heard, but felt as a visceral, physical force. This suggests a holistic vision of architecture, one where the sensory experience of a space was as critical as its visual grandeur or structural integrity. Sound was a tool, a technology for ceremony, for healing, and perhaps for accessing other states of reality. The silent stones are not so silent after all. They whisper of a forgotten science where the very air was sculpted to serve a higher purpose. The silent stones were not the only elements our ancestors mastered with such profound insight. In the vast, arid landscapes where water was more precious than gold, ancient engineers performed miracles of liquid logic. They transformed entire regions with networks so advanced they would challenge modern civil engineers. Consider the Persian empires, thriving for centuries in some of the world's driest climates. Their secret was the qanat, a breathtakingly simple yet brilliant invention. These were not mere ditches. A qanat was a subterranean canal, a gently sloping tunnel carved deep underground that tapped into water trapped in mountain aquifers. It would run for miles, sometimes dozens of miles, bringing a steady, cool flow of water to the surface without a single drop lost to evaporation under the scorching sun. This was gravity-fed engineering at its finest, requiring an intuitive grasp of hydrology and slope over vast, invisible distances. The creation of a single qanat was a generational project, a testament to long-term planning and a deep understanding of the Earth itself. It was this hidden web of tunnels that allowed deserts to bloom, supporting not just survival but the growth of mighty civilizations. This mastery of water was a global phenomenon. Far to the south, the Nabateans carved their magnificent city of Petra from rose-red cliffs, a place seemingly devoid of water, yet they too were hydraulic geniuses. In a landscape prone to sudden, devastating flash floods, they did not simply hide from the water, they tamed it. They engineered an intricate system of dams and diversion tunnels to channel these torrents away from their city. They carved vast cisterns directly into the rock face, some large enough to hold over 1.5 million liters of water, ensuring a reliable supply through the driest years. Pipes and channels carved with precision distributed this life-giving resource to homes, gardens, and public fountains throughout the city. They turned a barren canyon into a lush, prosperous capital by thinking with the water, by directing its power rather than fighting it. Even further back in time, in the Indus Valley, we find a society that built water management into its very foundations. The city of Mohenjo-Daro, flourishing over 4,000 years ago, possessed a level of urban plumbing that would not be seen again in Europe for millennia. Nearly every house had its own bathroom and a sophisticated drainage system. Covered brick-lined drains ran beneath the streets, complete with inspection points for maintenance. Wastewater was channeled away from living areas with a care for public health that feels startlingly modern. This was not a technology for the elite, it was a civic standard, demonstrating a collective understanding of hygiene and hydraulic principles. How did they achieve such precision in their clay pipes and graded channels without the metal tools we assume are necessary? The answer lies in an accumulated, practical wisdom passed down through generations. These ancient engineers possessed a deep, almost innate understanding of water pressure, slope, and flow. They knew how to capture a trickle and amplify it, how to store a deluge, and how to make the land itself work to sustain life. Their legacy is a powerful reminder that true engineering genius is not always about moving mountains, but about guiding a single drop of water on a journey of 1,000 miles. A single, precisely carved notch in a block of andesite stone can tell a story more compelling than an entire library. At the ancient site of Puma Punku in Bolivia, you find stones so perfectly cut they look machined, and within them, empty slots shaped like a capital I or a double T. These are the ghost imprints of metal clamps, and their existence poses a technological riddle that echoes across the ancient world. The metal used was not simple copper. It was a sophisticated alloy of copper, arsenic, and nickel, a blend that would have required advanced metallurgical knowledge and controlled, high-temperature smelting to produce. This was not a casual invention, it was a deliberate recipe for strength, and Puma Punku is not alone. Identical clamp fittings are found holding together the masonry of ancient Greek temples, in the foundations of Egyptian obelisks, and within the structures of Mesoamerican pyramids. This was not a local secret, it was a global standard. So what was their true purpose? The conventional explanation is that they acted like ancient rebar, providing crucial tensile strength to lock multi-ton blocks together against the relentless shifting of earthquakes. This makes logical sense, as many of these sites are in seismically active zones. Yet, the puzzle deepens when you consider the immense effort required to use them. Imagine the scene: workers first carving these complex, precise channels into granite or andesite, two of the hardest stones on Earth. Then, they would have needed portable forges to heat this special metal until it was a glowing, liquid pool, carefully pouring the molten alloy into the stone molds without cracking the block from the thermal shock. This was a logistical ballet of incredible coordination and skill. The sheer difficulty of the process leads some to wonder if their function was more than just mechanical. Could these metal clamps, often made from unique alloys, have served a different purpose? Some researchers point to the peculiar electrical properties of certain metals and suggest they might have been part of a larger, forgotten system, perhaps for grounding or energy conduction, a theory that remains highly speculative but speaks to the depth of the mystery. Whether for stability or something more enigmatic, these small metal pieces are giant markers of a lost technological consensus. They hint at a standardized solution to a universal problem of ancient engineering, a secret of joinery so effective that it was adopted by master builders from the Andes to the Aegean. The stones were not just stacked, they were woven together with metal threads, creating structures that were meant to last for eternity. These metal clamps were the invisible stitches holding ancient monuments together, but the true binding agent was a universal language of shape and number. Look upon the Parthenon in Athens, and you are not merely seeing a building, you are witnessing the golden ratio brought to life in marble. This specific mathematical proportion, often represented by the Greek letter phi, is found in the perfect relationship between the structure's length and height, in the spacing of its columns, and even in the intricate details of its sculptures. It is a ratio that appears repeatedly in nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. The ancient Greeks believed this proportion was the very signature of beauty and balance, and they encoded it into their most sacred architecture to create a visual harmony that feels instinctively right to the human eye. Yet this was not a secret confined to the Mediterranean. The same precise ratio can be found in the foundational dimensions of the Great Pyramid of Giza, its base perimeter compared to its height revealing a close approximation of pi, another fundamental constant. This is not a coincidence, it is a pattern. Travel to the east, and you will find the same principles governing the majestic Hindu and Buddhist temples of Angkor Wat and Borobudur. Their layouts are not random, they are physical representations of cosmic mandalas, intricate geometric diagrams of the universe. Every corridor, every tower, and every courtyard is positioned according to a sacred grid, a symbolic map meant to align the human realm with the divine order. This was architecture as a spiritual act, a way of building heaven on earth. How could cultures separated by vast oceans and millennia all arrive at the same complex mathematical principles? The construction of these geometrically perfect forms required more than just intuition. It demanded advanced knowledge. Master architects needed to understand irrational numbers, the properties of circles and triangles, and how to scale these perfect shapes to a monumental size. They employed precise measuring systems and tools that could transfer these abstract ratios from a small drawing onto a sprawling construction site with breathtaking accuracy. The recurrence of this specific geometric code points to one of two profound possibilities. Either there was a shared, ancient source of knowledge that spread across the world, a forgotten curriculum for sacred construction, or this represents a fundamental human intuition for harmonic design, a deep-seated recognition of the mathematical patterns that underpin our reality. In either case, these builders were not just stacking stones, they were writing a cosmic language in granite and limestone, using geometry as their alphabet to speak across the ages. That same geometric genius was built into the very substance of their world, a material that still endures while our own crumbles. To walk on a Roman road is to tread on a surface that has outlasted entire civilizations. And to stand beneath the dome of the Pantheon in Rome is to experience a miracle of material science. This dome, spanning over 43 meters, has not only survived for nearly 2,000 years, but it remains the world's largest unreinforced concrete dome, a record unbroken by modern engineering. The secret to this unbelievable longevity was a revolutionary material the Romans called opus cementitium. This was not the concrete we know today. Its recipe was a carefully guarded marvel, a formula so effective that it was lost for centuries following the empire's collapse. Modern scientists, using advanced tools like electron microscopes, have finally decoded its ingredients. The Romans mixed lime with a special volcanic ash known as pozzolana, along with chunks of rock and rubble. This combination created a slow-burning chemical reaction, a process of crystallization that actually strengthens the material over time, especially when in contact with seawater. Think about that for a moment. While our modern concrete harbors crumble in saltwater within decades, Roman concrete piers submerged for 2 millennia have become harder and more resilient. They engineered a material that actively heals itself, that grows stronger with age. This was an intuitive, empirical mastery of chemistry that we are only now beginning to replicate in laboratories. The Romans did not just build for their own time, they built for eternity. Their aqueducts, some of which still carry water today, and their colossal harbors are a silent, enduring reproach to our own disposable construction. The loss of this formula represents one of history's most significant technological regressions. Its full rediscovery could revolutionize modern sustainable building, allowing us to create structures that last for centuries, not just for a generation. The silent, stoic presence of Roman concrete forces us to ask a difficult question. In our pursuit of building faster and cheaper, what essential wisdom have we left behind in the dust? The same geometric principles that shaped their temples also guided them across the trackless ocean. Far from land, with only the sky and sea as reference, ancient mariners performed feats of navigation that modern sailors with GPS still find breathtaking. Picture the Polynesian voyagers setting forth across the vast emptiness of the Pacific in double-hulled canoes. Their destination was a tiny speck of land, an island smaller than a city block, thousands of miles away across the open ocean. They found it not by luck but by a masterful science they called wayfinding. This was a living navigation system, a mental blueprint of the cosmos and the sea. They memorized a star compass, knowing the precise rising and setting points of hundreds of stars, using them as fixed celestial signposts. By day, they read the ocean itself, interpreting the subtle patterns of swells as they reflected off distant, unseen islands. They watched the flight paths of specific seabirds, knowing how far they would travel from land before returning at dusk. This was not a collection of simple tricks. It was a holistic, integrated science passed down through generations in chants and stories. It was engineering applied to exploration, a way of turning the chaotic, unpredictable sea into a readable, navigable highway. This genius was not confined to the Pacific. Centuries before the age of European exploration, The Phoenicians are believed to have circumnavigated the entire continent of Africa, a voyage of immense duration and staggering difficulty. The Vikings, too, crossed the violent, icy waters of the North Atlantic, navigating by sunstones, crystals that could pinpoint the sun's location even through dense cloud cover, to eventually make landfall in Newfoundland. How did they know where they were without a magnetic compass or an accurate clock to determine longitude? They possessed an intimate, empirical knowledge of astronomy. By measuring the height of the North Star above the horizon, they could determine their latitude with remarkable accuracy. They learned to read the language of the wind and the currents, understanding the great river-like flows within the ocean that could carry them to their destination or dash them against hidden rocks. These ancient explorers carried the most crucial blueprints not on parchment, but in their minds, cognitive maps of the world built from a lifetime of observation and a deep ancestral connection to the natural world. They were living instruments, their very senses calibrated to the rhythms of the planet. Perhaps the most overlooked blueprint of all is the one that transforms a simple rope into a tool of immense power. We often picture the ancient builder's toolkit as primitive, yet the compound pulley system represents a mechanical revolution. While the brilliant mind of Archimedes is credited with its formal description, the sheer scale of monuments like the Egyptian obelisks points to its use centuries earlier. Imagine a single granite needle towering over 100 feet tall and weighing more than 400 tons. How do you lift such a thing from a horizontal position in a quarry to a vertical one, planting it perfectly on a tiny stone pedestal without it shattering? The answer likely lay in a symphony of simple machines working in concert. A massive earthen ramp would have been built, but the true magic happened on its slope. Teams of laborers, perhaps hundreds strong, would have pulled on multiple ropes threaded through a series of wooden pulleys. Each pulley sheave they added did not just make the job easier, it multiplied their collective strength exponentially. This mechanical advantage meant that the combined force of a few dozen people could, in effect, lift the weight of a small mountain. It was physics made tangible. The real genius, however, was not in the pulley itself, but in the flawless choreography surrounding it. The lift was a ballet of coordinated effort, with foremen directing the pull, others placing wooden levers for micro-adjustments, and teams inserting rollers beneath the stone the moment it shifted. Modern experiments have proven this is possible. Using reconstructed techniques, volunteers have moved and raised colossal stones. Yet these projects reveal the true secret. The most critical component was not wood or rope, but organization. The ancient blueprint was a system of human logistics so perfect it functioned like a machine itself. This shifts the entire mystery. The question is no longer what magical tool they possessed, but how they achieved such a seamless, large-scale operation, managing thousands of workers with a precision that modern project managers would envy. Their greatest invention may not have been a device, but a method. That seamless fusion of human coordination and simple physics reveals a deeper truth about these projects, one that goes far beyond mere construction. In the ancient world, the engineer and the priest were often one and the same. Building was not a purely technical profession. It was a sacred act, a form of devotion etched in stone. When a ziggurat rose in Mesopotamia, its stepped tiers were not just architectural features, they were a symbolic staircase, a bridge connecting the earthly realm to the heavens above. Its orientation was meticulously calculated to align with specific stars or the path of the sun, physically rooting the temple in the cosmic order. Every decision, from the dimensions of a chamber to the type of stone used, was imbued with spiritual meaning. The quarrying, transportation, and placement of each block were rituals in themselves, performed with a reverence we might reserve for a holy sacrament. This spiritual imperative fundamentally changes our understanding of the immense effort involved. The near-impossible precision was not an obsessive technical standard, it was a theological requirement. A wall that was off by a fraction of an inch was not just a flawed wall, it was a flawed prayer, a structure misaligned with the divine blueprint it was meant to embody. This explains why societies would invest generations of labor and unimaginable resources into a single project. They were not building for kings or for vanity, they were building for eternity and for the gods. The Great Pyramid was not just a tomb, it was a machine for resurrection, its shafts and chambers designed to guide a pharaoh's soul to the stars. The Hindu temple of Angkor Wat is a literal map of the Hindu cosmos, with its central towers representing the mythical Mount Meru, the axis of the world. The engineering challenge was therefore twofold: to create a structure of immense physical stability while simultaneously ensuring it perfectly conformed to an intricate, invisible web of symbolic and ritualistic rules. The stone had to bear weight, but it also had to channel spiritual energy. This holistic vision of creation, where science, art, and religion were inseparable, may be the most profound blueprint we have lost. It forces us to ask, did this spiritual drive, this need to build heaven on earth, unlock a level of focused human potential that our modern, segmented world struggles to comprehend? The true measure of ancient genius is not always found in towering monuments, but sometimes in objects small enough to hold in your hands. In 1901, sponge divers off the coast of a tiny Greek island named Antikythera stumbled upon a shipwreck. Among the statues and pottery, they recovered a lump of corroded bronze, so encrusted and calcified it seemed like a piece of rock. It was set aside for nearly a year before an archaeologist noticed a gear wheel embedded within the decay. This unassuming object, now known as the Antikythera Mechanism, would shatter our understanding of classical technology. It was, in essence, an ancient computer. Dating back to the 2nd century before the Common Era, this device was a masterpiece of miniaturization. Its wooden case contained a complex clockwork of at least 30 interlocking bronze gears, precisely cut by hand. By turning a hand crank on the side, the entire mechanism would whir to life, moving dials and pointers across several faces to display a breathtaking array of celestial information. It could predict the positions of the sun and moon, show the phases of our lunar companion, and even track the cycles of known planets. One of its dials was a calendar for the Panhellenic Games, including the original Olympics, turning this into both a scientific instrument and a social planner. The sophistication of its gear trains is staggering. It used a differential gear, a complex arrangement previously believed to have been invented in the 16th century, to account for the moon's irregular orbit. This single component represents a leap in mechanical engineering that would not be seen again for over 1,000 years. How could a civilization we picture crafting statues and temples produce such a precise and intricate machine? The mechanism implies a hidden world of advanced knowledge. Its creator needed a profound grasp of astronomy to understand the planetary cycles it modeled. They required advanced mathematics to calculate the gear ratios, some involving prime numbers with over 50 teeth, to accurately mirror the movements of the heavens. And they possessed metalworking skills of the highest order to craft these tiny, perfect components without the aid of industrial tools. This was not a one-off curiosity. It is a tangible piece of evidence, a single surviving page from a vast library of lost technical manuals. Its very existence on a trading ship suggests it was not unique, that such devices were known, if not common, within the Hellenistic world. It forces a complete reassessment of the technological ceiling of the classical era. If they could build this, what else did they create? What other advanced devices, perhaps even more complex, have been lost to the corrosion of time or the fires of war? The Antikythera Mechanism is a ghost in the machine of history, a silent witness to a level of engineering prowess we are only now beginning to hear. That intricate bronze gearwork speaks of a civilization that could calculate celestial motions, but another kind of genius lies in walls that can dance with the earth. Walk through the ancient streets of Cusco, Peru, and run your hand over the stonework. You are not touching a flat, orderly wall of bricks. You are feeling a gigantic, three-dimensional jigsaw puzzle carved from solid granite. Enormous blocks, some with 12 or more sides, fit together with such seamless precision that the joints are virtually invisible. This is polygonal masonry, and its chaotic beauty is a deliberate masterpiece of engineering. The true brilliance of this design reveals itself not in stillness but in chaos during an earthquake. While a rigid, mortared wall would crack and crumble under the seismic stress, these polygonal walls have a secret, dynamic stability. The stones are not glued in place, they are held by gravity and friction. When the ground shakes, the entire structure flexes. The individual blocks shift, they slide and rotate minutely against one another, absorbing and dissipating the violent energy. Then, when the tremor passes, they settle perfectly back into their original positions, locked together once more. This is architecture that is alive, designed to move with the planet rather than fight against it. Achieving this required an almost supernatural level of skill from the stonemasons. Imagine the challenge. Each multi-ton block was a unique, irregular shape that had to be custom fit to its neighbors on all sides. The masons had to visualize the final, interlocking pattern in 3 dimensions, then painstakingly carve the complex angles and curves into unforgiving granite using only stone hammers and bronze tools. There was no room for error. A single miscut could ruin the block and compromise the entire wall's integrity. This was an immensely time-consuming process, a testament to patience and an empirical understanding of physics that feels almost prescient. These builders, living millennia before the science of plate tectonics was conceived, had deduced through observation and experience exactly how to build for survival in an unstable world. They looked at the cracking ground and did not seek to overpower it with rigid strength. They chose to harmonize with it through flexible intelligence. This same seismic-resistant blueprint appears in ancient structures from Greece to Japan, a global whisper of a lost architectural truth that sometimes the strongest thing you can build is something that knows how to yield. The same stones that danced with earthquakes also stood perfectly still to catch the light of the dying sun. High in the Andes, the Intihuatana stone at Machu Picchu is far more than a carved rock. Its name means the hitching post of the sun, and it functions with breathtaking precision as a solar clock. On the equinoxes, the sun stands directly above the pillar, casting no shadow at all, a moment of perfect celestial balance captured in granite. This was not an isolated feat. Far to the north, in the arid expanse of New Mexico, the great houses of Choco Canyon are studded with petroglyphs, spiral carvings that become instruments of light and shadow. A dagger of sunlight slices through a carefully placed opening to bisect the center of a spiral only on the summer solstice. Even more remarkably, the architecture itself, the long, straight walls and distant windows, aligned to mark the moon's far more complex journey. The moon does not simply rise and set in a repeating pattern. It follows an 18.6-year cycle, a long, slow wobble between its extreme rising and setting points. The builders of Choco encoded this entire cycle into their structures, a project that would have required generations of patient, meticulous observation to complete. This is the profound work of archaeoastronomy, the science of decoding how ancient cultures read the sky. For these societies, tracking time was not about checking a date on a phone. It was the very foundation of survival and social order. Knowing precisely when the rains would come dictated when to plant crops. The position of a star or the phase of the moon signaled the time for a sacred festival or the start of a new year. This celestial knowledge was a form of power held by the priest astronomers who could literally predict the turning of the world. To build a temple that captures a single, specific sunbeam on one day of the year required more than just architectural skill. It demands the ability to translate decades, even centuries, of accumulated data into a permanent, immovable stone alignment. It means understanding the Earth's tilt, the precession of its axis, and the subtle dance of other celestial bodies, all without a single written formula or a telescope. The structures themselves became the textbooks, the observatories, and the calendars, all fused into one. This reveals a world where engineering was not separate from cosmology, but an extension of it. To build was to reach into the heavens and bring a piece of that cosmic order down to Earth, creating a stable point in a turning universe. That same celestial precision had to be mirrored on the ground, in the monumental task of managing the people who turned the blueprint into stone. The Great Wall of China did not snake across mountains by magic, and the pyramids did not rise from the sand by wishful thinking. These achievements required the synchronization of tens of thousands of individuals, a colossal feat of social engineering that rivals the architectural marvels themselves. How do you house, feed, and motivate an army of laborers for decades? The popular image of whip-driven slaves is shattered by the evidence. At Giza, excavations have revealed bakeries capable of producing thousands of loaves of bread daily, and the remains of cattle, fish, and other provisions on a massive scale. These workers were not starving conscripts. They were skilled, well-fed artisans and laborers who lived in dedicated barracks near the construction site. This points to a highly organized administrative system, a bureaucracy of immense capability. Think of the supply chains required just for sustenance, a constant river of grain, water, and fuel flowing into the desert to support this city of builders. The logistics extended far beyond food. There were toolmakers to supply copper chisels, quarries to manage for stone, and transport captains to coordinate the movement of materials. This was not a chaotic mob. It was a society in miniature with a clear hierarchy of overseers, engineers, and specialized work gangs. The project management skills on display were as advanced as the architectural plans. Someone had to schedule the quarrying so that blocks arrived just as a new course of the pyramid was ready. Someone had to implement quality control, ensuring that each stone met the exacting standards for its place in the grand design. They had to solve problems in real time, from a cracked block to a delayed shipment, without ever halting the immense, slow-motion ballet of construction. The true, hidden blueprint for these wonders may not have been a drawing of angles and dimensions, but an organizational chart. It was the social contract, the shared belief or compelling system that enabled such vast, sustained collaboration. This was the alchemy that turned scattered human effort into a single, precise, and directed force capable of moving mountains. A polished granite sarcophagus sits inside the Great Pyramid, its surface so perfectly smooth and its corners so sharply exact they seem machined. Mainstream archaeology tells us the tools for this work were simple copper chisels and stone hammers. But when modern stoneworkers, using precise replicas of these tools, attempt to recreate even a small section of this finish on the same hard stone, they encounter a stark reality. The soft copper chisels blunt almost immediately against the unyielding granite, making the work incredibly slow and demanding a level of patience that borders on the unimaginable. This is not a question of skill, but of basic material physics. How could a soft metal like copper effectively shape one of the hardest stones on Earth with such flawless results? This frustrating gap between the tools we have found and the artifacts they supposedly created fuels one of the most compelling debates in ancient studies. Some researchers point to the evidence left on the stones themselves. In Egypt, we find drill holes in cores of basalt, a volcanic rock even harder than granite. The spiral grooves left in these cores are uniform and deep, suggesting the drill bit was not merely scraping, but was fed into the stone with immense, consistent pressure. A simple copper tube with sand as an abrasive, the traditional explanation, struggles to account for this efficiency. This has led to speculation about lost techniques, perhaps involving abrasive compounds far more effective than common sand. Imagine using a slurry of water and corundum powder, the mineral that forms rubies and sapphires. This substance is significantly harder than granite and could have allowed those copper tools to act merely as a carrier for a truly effective cutting agent. Other theories venture into more complex technology. Could the ancients have possessed saws with blades embedded with diamond or other precious stones, creating a tool that could slice through stone like a modern diamond-tipped saw? The precise, flat surfaces on some granite blocks even suggest the potential use of a primitive lathe or milling machine, a device for rotating the stone against a fixed cutting tool to achieve that impossible flatness. The core of the debate is not necessarily about futuristic technology, but about acknowledging a possible blind spot in our historical vision. We must confront two possibilities, both profound in their own way. Either ancient craftsmen achieved a level of skill, patience, and collective will that we can scarcely comprehend, dedicating lifetimes to a single stone box with a focus that transcends our modern mindset, or our picture of their technological toolkit is simply incomplete. Perhaps the most advanced tools, the ones made of perishable materials or the secret formulas for super abrasives, have been lost to time, leaving behind only the magnificent, silent stone that refuses to tell all its secrets. The polished granite sarcophagus and the pyramid that houses it are not solitary wonders. An identical architectural impulse appears across the globe, in the jungles of Mesoamerica and the river valleys of Mesopotamia. How do we explain the startling fact that cultures separated by oceans and millennia all chose to build massive pyramidal structures, aligning them to the cosmos with precision? The conventional view holds that this was simply independent invention, the logical conclusion any society reaches when it wants to build something tall and stable with stone. But the parallels run far deeper than mere shape. The Great Pyramid of Giza, the Pyramid of the Sun at Teotihuacan, and the Great Ziggurat of Ur all share a sacred connection to the heavens. Their stairways and causeways are oriented to celestial events. Their dimensions often encode mathematical constants, and their very purpose was to bridge the human and the divine. This is more than a coincidence of form, it feels like a consensus of purpose. Could there have been a single, forgotten source for this architectural blueprint, a progenitor civilization whose knowledge sailed across the seas? The idea of ancient transoceanic contact, while controversial, is a tantalizing solution to this puzzle. Perhaps seafaring peoples, long before the recognized age of exploration, carried the seeds of this sacred geometry from one continent to another, planting the same idea in different soils. Yet, even if we dismiss the possibility of direct contact, the mystery only deepens. What does it mean if the human mind, regardless of time or place, independently arrives at the same complex synthesis of engineering, astronomy, and spirituality? This points to a universal human genius, a shared cognitive blueprint hardwired into our species. We are driven to reach for the sky, to build our mountains, and to encode our understanding of the universe in stone and angle. The true connection may not have been a sunken continent or a forgotten fleet, but a fundamental set of principles about mass, stability, and sacred geometry that different cultures discovered and perfected on their own. This meta-blueprint, this innate understanding of how to build heaven on earth, might be the most profound legacy of our ancestors. It suggests that the impulse to engineer the impossible is not a fluke of history, but a defining trait of humanity itself. That impulse to build heaven on earth did not stop at temples and tombs. It extended to the very mountains and valleys themselves. Ancient societies were not just master architects, they were the world's first environmental engineers, reshaping entire landscapes on a breathtaking scale. High in the Peruvian Andes, the Inca did not simply farm the steep slopes, they transformed them into a vast, cascading staircase of green. These terraces were far more than flat planting surfaces. They were a sophisticated system for controlling erosion, trapping precious water, and creating a multitude of microclimates. At the site of Moray, we see this principle perfected in a stunning natural depression. The Inca carved a series of concentric circular terraces deep into the earth, each level descending many meters. The temperature difference between the top and bottom terraces can be as much as 15 degrees Celsius. This was not an accident. It functioned as a massive, open-air agricultural laboratory where Inca botanists could experiment with crops and develop new strains suited to different altitudes and growing conditions. This reveals a profound, systemic understanding of the environment. They were not fighting the land, they were collaborating with it, using its own contours and physics to enhance its productivity. This same ambition to reshape the world is found on the other side of the globe, on the plains of England. Silbury Hill is the largest prehistoric man-made mound in Europe, a colossal pyramid of earth built around 4,700 years ago. It is composed of over 500,000 tons of chalk and clay, all meticulously layered and compacted by hand. To put that in perspective, the volume of earth moved is comparable to that of a modern mega-project, like a major highway interchange. Yet this was achieved without a single wheelbarrow or draft animal, using only woven baskets, antler picks, and human muscle. This was not a random pile of dirt. Its construction was a generations-long project, requiring the coordinated effort of thousands of people, all directed by a master plan. The purpose of Silbury Hill remains enigmatic, likely ceremonial, but its message is clear. These societies possessed the vision and the organizational will to alter their world in a permanent, monumental way. They understood soil mechanics, knowing how to layer different materials for stability and drainage to prevent their creation from simply washing away over the centuries. They grasped hydrology, designing their earthworks to manage water flow, whether to irrigate terraces or to keep a sacred mound dry. This was engineering on a grand geological scale, a testament to a holistic worldview where the built environment was not separate from nature, but an enhancement of it. They looked at a mountain and saw not an obstacle, but a canvas for a new, more fertile reality. That self-healing Roman concrete was not a singular miracle, but part of a global pattern of material mastery. Ancient builders seem to possess a secret code for durability, an understanding that the true test of a structure was not how quickly it rose, but how gracefully it could endure the relentless passage of time. They engineered for eternity, and the proof is in the mortar. While our modern concrete often fails within 50 years, medieval castles stand firm after 1,000. Their secret was in the mix. European masons often added unexpected organic materials to their lime mortar, things like animal blood, cheese, or even beer. This was not superstition. We now understand that the proteins in these substances acted as plasticizers, altering the mortar's crystalline structure to give it a slight flexibility. This flexibility was crucial, allowing the walls to shift and settle minutely with seasonal changes and ground tremors without developing catastrophic cracks. It was a brilliant, empirical solution to a problem of physics, discovered through generations of trial and error. The ancient Egyptians pursued a similar goal with a different recipe. In the blazing heat, they relied on gypsum-based mortar. Gypsum sets very slowly, a property that would frustrate a modern contractor on a deadline. But for the builders of the pyramids, this slow cure was a feature. It allowed the massive stone blocks to settle into their final positions gradually, the mortar accommodating tiny shifts over months or even years, creating a monolithic whole that moved as one unit rather than a collection of rigid, brittle parts. This long-term perspective is the most crucial part of the forgotten blueprint. These societies were not building for a single lifetime or a corporate quarterly report. They were building for civilizations yet unborn, investing in a legacy of stone. Their material choices reflected a profound wisdom, a deep, intuitive grasp of how substances behave not just in the moment of construction, but across centuries of frost, rain, and seismic shock. They prioritized resilience over speed, choosing the method that would last 1,000 years over the one that would take only 10. Today, as our own infrastructure shows alarming signs of premature decay, we are finally looking back to these ancient recipes. Scientists in laboratories are now actively studying Roman concrete and medieval mortars, using advanced spectrometry to decode their molecular secrets. The goal is to reverse engineer this ancient wisdom, to create a new generation of sustainable building materials that can self-heal, flex with environmental stress, and stand as a testament to our time for millennia to come. We are relearning the simple, profound truth that the greatest engineering is not about how fast you can build, but how long what you build will endure. A master builder did not need a scroll to remember the angle of a pyramid slope. The most vital blueprints were held in human memory, passed from one generation to the next through the precise and demanding art of oral tradition. In a world before widespread literacy, complex engineering designs were not lost because they were never written down in the first place, they were lived. An apprentice would spend decades at the side of a master, not just carrying tools, but absorbing a vast library of knowledge through stories, chants, and ritual. The perfect ratio for a column, the sequence for laying a foundation, the correct chant for mixing mortar, these were not separate pieces of information. They were woven together into a single, cohesive narrative, a song of creation that was both a spiritual guide and a technical manual. The consistency we see in architectural styles, where temples built centuries apart share identical proportions and alignment, is the direct result of this rigorous system of cognitive transmission. This required a form of intelligence we have largely set aside, one built on immense pattern recognition, flawless spatial memory, and verbal precision. A single misplaced word in a ritual chant could mean a misremembered formula, so the language itself became a tool of exquisite accuracy. The true fragility of these ancient wonders is now clear. The stone has proven incredibly resilient, but the living knowledge required to shape it was far more vulnerable. When a master craftsman died without a fully trained successor, or when a society collapsed and its oral traditions were broken, entire libraries of engineering genius vanished in a single generation. The stone remained, but the voice that knew how to command it fell silent forever. These silent stones might have been humming with a power we can no longer see. A growing chorus of speculative thought suggests that the true purpose of ancient monuments extends far beyond the ceremonial, proposing they were active components in a planetary energy grid. This radical hypothesis views sites like the Great Pyramid or Stone henge not as isolated shrines, but as interconnected nodes designed to harness the Earth's own subtle forces. The concept revolves around telluric currents, slow-moving electrical flows that travel through the ground. Proponents argue that the specific placement of these structures, often on geological fault lines or atop underground aquifers, was no accident. They were strategically located to tap into these terrestrial power sources, much like plugging into the planet's own electrical outlet. The very materials used in construction could have played a role. Granite, a stone common in many ancient sites, is slightly radioactive and possesses piezoelectric properties, meaning it can generate a small electrical charge under mechanical stress, such as the immense pressure of the stones above it or the subtle vibrations of the Earth itself. Inside pyramid chambers lined with such stone, could a measurable energy field have existed? Further fueling this theory are artifacts like the alleged Baghdad batteries, terracotta pots containing a copper cylinder and an iron rod that, if filled with an acidic electrolyte like vinegar, can produce a small voltage. While mainstream archaeology interprets them as storage vessels for sacred scrolls, their design is electrically functional. This opens a provocative question. If they knew how to generate a charge, however small, what might they have been powering? These ideas push against the boundaries of conventional history, suggesting our ancestors may have perceived the world in terms of energies and frequencies we are only now relearning to measure. They might have built resonators to amplify the planet's natural hum, the Schumann resonances, which are ultra-low frequency waves that constantly circle the Earth between the ground and the ionosphere. Could these structures have been designed to sync human consciousness with this global heartbeat for healing or spiritual purposes? Whether these theories hold scientific weight is fiercely debated, and they remain on the fringe of accepted research. Yet their value lies not in proving a forgotten technology, but in challenging our assumptions. They force us to ask if we are looking at these ancient wonders with a fundamental blind spot, seeing tombs and temples where a more sophisticated civilization saw power plants and resonators. The mystery endures because the stones give up their form easily, but their true function remains locked away, a secret perhaps not of stone, but of energy itself. The silent stones are finally beginning to speak our language. Modern science, armed with tools that see through solid rock and measure angles to within a fraction of a millimeter, is systematically reverse engineering the ancient world. Ground-penetrating radar sweeps across the desert sands, revealing the hidden chambers and internal ramp structures of pyramids like the Bent Pyramid at Dosha, mapping its secrets without ever turning a shovel of earth. Meanwhile, high-resolution 3D laser scanners capture the surface of a single stone block at Puma Punku, creating a digital model so precise it can be rotated and analyzed from every angle. This digital replica shows us that the cuts on these andesite blocks are not just flat, they are perfectly planar, and the complex notches are identical in depth and width, suggesting the use of a standardized template or a remarkably consistent technique. This is no longer speculation, it is quantifiable data. With these digital models, engineers can run sophisticated computer simulations, applying virtual earthquakes to the polygonal walls of Cusco to watch how the stones dynamically shift, or modeling the immense weight distribution over the Pantheon's dome to understand its enduring strength. This computational power allows us to test construction theories on a screen, calculating the exact number of workers and the optimal pulley configurations needed to raise an obelisk, transforming historical guesswork into a rigorous engineering experiment. The most direct application of this research is happening in material science labs around the world. By analyzing microscopic slivers of Roman concrete with electron microscopes, scientists have identified the unique crystalline structure that allows it to self-heal. This ancient recipe is now inspiring the development of new, more resilient cement. Imagine a future where bridges and seawalls contain a special additive that activates when a crack forms, filling it with new crystals and extending the structure's life for centuries. We are not merely solving ancient puzzles for the sake of knowledge. We are mining the past for practical solutions to modern crises. The ancient challenge of building sustainably with local materials and designing structures to withstand natural disasters is precisely the challenge we face today. Their blueprints, etched in stone and now decoded with light, are becoming a surprising wellspring of innovation, proving that the path to a more resilient future may be paved with the wisdom of a forgotten past. Our own civilization champions a story of relentless upward progress, but the silent testimony of these ancient stones tells a different tale. They present a fundamental challenge to the linear narrative of history, the comforting idea that we began as primitives and have marched in a straight, unbroken line toward our current technological peak. The evidence carved into granite and limestone suggests a more complex rhythm, a series of great cycles where knowledge surges to a breathtaking crest, only to recede and be forgotten, leaving only enigmatic ruins as markers of a lost zenith. This is a deeply humbling realization. It forces us to confront the possibility that entire libraries of science and engineering can vanish, not in a library fire, but in the collapse of a society, in the breaking of an oral tradition, in the silence that follows a fallen empire. We look upon the Antikythera Mechanism and see a level of mechanical sophistication that disappeared for over a millennium. We study self-healing Roman concrete, a formula lost for 1500 years. This is not a story of slow, steady improvement, but of catastrophic forgetting. The true genius of our ancestors, therefore, may not have been the specific tools they wielded, but the incredible adaptability of the human mind itself. It is the raw cognitive ability to observe the world with intense clarity, to discern its underlying patterns, and to manipulate its physical laws using nothing more than stone, rope, and an unwavering will. They achieved the impossible not because they had magic, but because they possessed a profound and practical intelligence that turned simple materials into instruments of cosmic ambition. This perspective shatters modern arrogance. It asks a difficult question of our own time, perched atop a vast and fragile digital archive. How much of our own knowledge is truly permanent? If a global catastrophe struck, how much of our science would survive in a form that could be rebuilt? The forgotten blueprints are a stark warning about the brittleness of civilization. They remind us that our technological edifice is not a permanent monument, but a flickering candle in the long night of history. Ultimately, these structures are not just relics to be studied. They are a mirror held up to our own potential and our own fragility. They tell us that the capacity for greatness is a constant in the human spirit, but its expression is fleeting. The true lesson of the ancients is not about how they built, but about what we, with our own minds and hands, might yet achieve, and what we must diligently protect from the relentless tide of time. Our journey through these forgotten blueprints reveals a stunning tapestry of human achievement. It is woven with threads of profound knowledge, meticulous skill, and a deep spiritual connection to the cosmos. We have walked among structures that defy simple explanation, from pyramids aligned to the stars with laser-like precision to walls that dance gracefully with earthquakes. The undeniable truth is that pre-modern societies engineered the impossible not through magic or alien intervention, but through a masterful application of observed natural principles. They looked to the flowing water and understood hydrology. They studied the swinging stars and mastered astronomy. They felt the tremble of the earth and designed for flexibility. This was paired with a sophistication in social organization we are only beginning to appreciate, the ability to coordinate thousands of people with a shared purpose over generations. Perhaps most humbling of all, they possessed a long-term vision we often lack today, building not for a lifetime but for millennia. These structures stand as permanent questions carved in stone, challenging us to look deeper into our own past and reconsider the very timeline of human progress. They are a powerful reminder that innovation and genius are not the sole property of the modern digital age. True brilliance has always been a human trait. As we continue to decode their secrets with lasers and electron microscopes, we do more than just solve fascinating historical puzzles. We are reclaiming a lost heritage of human capability, a legacy of patience, observation, and collaboration. Let these ancient wonders inspire you to question the narratives you are told about our primitive ancestors. Let them encourage you to recognize the incredible potential that lies within focused, collective human endeavor. What could we achieve if we combined our modern tools with their timeless wisdom? If this exploration into humanity's lost genius has captivated you, subscribe for more journeys into history's greatest mysteries. We would love to hear which ancient marvel intrigues you the most, so please share your thoughts in the comments below.